So today's lesson is all about similar figures. Remember, congruent means same size and same shape, but similar figures have the same shape but different sizes. We use this squiggly symbol to represent similar, so you can remember like squiggle, similar. In similar figures, corresponding angles are congruent, so all the angles would be the same measure. So see here, the angles all correspond, they're the same measure. However, corresponding sides are proportional. So for example, if you look at GI and FB, they're not the same size, but they are all in proportion to make the same shape. So when you're reading your similarity statements, all of the rules about congruency for angles still hold. So angle G is congruent to angle F, angle I is congruent to angle B, angle H is congruent to angle D. And it is really helpful to use colored pens or pencils if you have them for this to keep track of what's congruent. Also, your corresponding sides would be proportional. So for example, GI is in the same spot as FB, so you would make a fraction GI over FB. That's basically your scale ratio or scale fraction for all of them. The same thing works for IH and BD, so that would be your next fraction. And the other one would be first and last, so blue and orange, GH and FD. So those are your three equal fractions. So you basically have a proportion with three parts, which you could break up three ways. So you could take the first two, those would be equal. You could take the second two, would also be equal, and the first and the last would also be equal. Make sure that the top and the bottom of every fraction are corresponding in the similarity statement. So I would not necessarily look to your pictures for these because sometimes the picture can be deceiving. For example, in this picture, I don't know if GI corresponds to BD, it would be F. I know it's not FD because the sides don't look the same, but it's a little bit unclear. So always look at your statement to see what is corresponding. A scale factor is just what I was saying there. So it's the ratio of corresponding sides. So for example, in this picture, GI corresponds to BF, so the scale factor would be 15 to 10. GH corresponds to FD, that would be 9 to 6. And IH corresponds to BD, which would be 12 to 8. All of your scale ratios should simplify to the same thing, which in this case is 3 over 2, or 3 to 2 would be the scale factor from the first triangle to the second triangle. Some examples. So here, if you have one side is 5, one side is x, the figures are similar with scale factor 3 to 4, and you need to solve for x. So first thing to do would be write a proportion where one side is your scale factor, 3 to 4. The other side is your sides in order that you see them, 5 to x. Then you simply cross multiply, so 3x is equal to 20, and then you're dividing. You can get decimals and fractions. Probably on pages 5 through 8 there won't be any crazy decimals, but in this case it ends up being 6.6 repeating, which is fine. Example B, we have some crazy polygon. Same rules still apply, so you need to solve for x. So what I like to do is use a color to highlight one side that I know. So I know LD is 60, so I used pink. I look at my statement. LD corresponds to first last, so it would be AR. So LD corresponds to AR. So my part of my fraction is going to be 60 over x. And I have that here, 60 over x. The other one we know about is LO. So LO is 50. If you look in your statement, LO is the first two, and the first two in the second figure are AM. So LO corresponds to AM. So 50 over 40 would be the second part of my proportion. Then you're just cross multiplying. 50x equals 2400. Divide by 50 and you have 48 units. If you're up to here in the video and you have any questions or anything doesn't make sense, please just pause and ask me. You also might want to pause and take a look at the guiding questions on the back of the tic-tac-toe board and see if you can answer anything yet. Here's another example where we have some more complex expressions, but it's still the same exact process. So look at what you're given. So we know dA is one given side. Look at your statement. dA corresponds to SC. So dA SC gives us 14 over 24. Next thing you're given in the first one is 2x minus 1. And if you look at that is dn, so first and last, corresponds to SC, first and last. Or I'm sorry, SE, first and last. So that would be 4x minus 3. So there's dn SE, your second fraction, 2x minus 1 over 4x minus 3, your second fraction. Then you're just cross multiplying and solve. Remember that you distribute, so don't forget to distribute the 14 not only to the 4x but also to the negative 3. Here you're distributing 24 not only to 2 but also to negative 1. So you can just look over how I solved this and make sure that you understand the solving process. Again, if anything's unclear, please pause, please ask. You also might want to pause and take a look at the guiding questions again. See if you can answer any. These examples, I think, don't come up really until page 7 and 8. So you might have one that gives you the scale ratio of the figures, and it gives you all of the sides in the first figure, and they ask you to find the perimeter of the second figure. So perimeter of triangle joy, you could add them up, you get 36. Then you're writing your proportion using the scale ratio first, 2 over 5. Is equal to the perimeter of triangle joy over perimeter of triangle full. So we have 2 over 5. We found perimeter of triangle joy to be 36. We don't know the perimeter of triangle full, so you can call it x. Again, cross multiply, which I know you're great at, and then solve. You get perimeter to be 90. It is much faster and probably less likely for you to make errors if you find the perimeter first and just do one proportion rather than finding each side individually. And one more example where the triangles are kind of inside each other. So we know triangle ORS is similar to triangle HRE in the statement. And again, look at what you're given. So one piece that I'm given is RS. Well, not that we're given RS, but we need to use RS. So, but you could figure out what RS is based on the fact that you know the whole thing is 30. SE is 3. So basically 3 plus what gives you 30? RS should be 27. So you have to figure that out first. RS in the statement corresponds to RE, second and third. RS, RE. So it's 27 compared to 30. RS, RE, 27, 30, your first fraction. Your second fraction is technically the bottom of this figure, so OS, which in your statement, first and third, corresponds to first and third HE, OS, HE. So your second fraction is OS compared to HE, which is 2x plus 4 compared to 4x minus 5. Now that you have your proportion set up, you can cross multiply and solve. Again, this one is a weird decimal, but you probably won't have weird decimals in your practice packet. Doesn't mean they're not possible. So again, please stop the video, ask any questions if anything didn't make sense. You can also ask people in your group if I'm busy with somebody else, that's fine. And make sure that you try the guiding questions on the back of the tic-tac-toe and ask if anything's not clear. And also let me know when you're done with the guiding questions so I can check them out. Thanks.